My name is Ryan. As Judy said, thank you very much. This is really neat for me to be here. Jim, I don't know where he went. He kind of set me up. I'm just here to really talk about what I love, and your area is completely new to me. So I'm learning as much tonight as hopefully you will, just learning a little bit about the space station. As I worked with Maurizio to put this together, he shared with me that people are just interested in something outside what they're doing, give us something new. And so I think for a lot of you, hopefully you'll learn something here tonight that you haven't heard before. I have been working for the space station program at NASA for about 20 years now. Oh, there it goes. NASA itself, as you know, covers the whole gamut of aerospace and outer space. My very tiny knothole is just space station. So that's what I'm going to share more with you about tonight. A lot of people don't realize how long space station's been around. 1984, you can go Google a Ronald Reagan weekly radio address where he introduced space station to the world. And it will serve the cause for peace and create a better life for all of us here on Earth. But he went into three main areas that he hoped we would get from space station. And I kid you not, that vision today is still exactly what we're doing. He had hoped for a laboratory, a platform to do fundamental research, one to help lives here on Earth, but also to further our ability to go beyond low Earth orbit. He hoped to build international collaborations, which we have done. We work with international partners every single day in the office. And he hoped to build an industry in space, to bring in commercial industries and build an economy starting from a space station platform. Everything he said in 1984 is still what we're doing today. So here's what we built. We built the space station starting, our first element went up in 1998. We've had permanent manned presence since 2000. It's quite large. This is actually to scale. The span of the solar arrays cover an entire NFL football field, end zone to end zone. I actually have one with Texans end zones in it. I should have found that one for this presentation. That would have been better. Sorry, Jim. Probably not Texans fan. This is our current crew who's on board the space station. We currently have a European astronaut, an American astronaut, and a Russian cosmonaut. Typically, we have 6 on board the space station. We're just the month of July, we have what we call an indirect handover, where the ships going back and forth are a little bit off, and so we only have 3 right now. Space station weighs about 900,000 pounds. It's about as big as a 6-bedroom house inside, volumetrically. About, I don't know, I was looking at the numbers today, 232 people have visited the space station. Many, many years, many, many shuttle flights to build it. I have lots of stories if you want to stay around after. But I talked about the international piece that Reagan had hoped we would accomplish with it, and we really have. Other agencies use some of the collaborations we have done to help build their interface for their industries. We have 5 primary partners with the Canadians, the Japanese, the Russians. I say the Europeans because the Europeans in and of themselves are a combination of about, I'm going to get the number wrong, so don't quote me, around 20 different sovereign countries in Europe. So they have a difficult job. They have to get themselves together and then come to the table to work with our partnership. But overall, about 15 nations. There are about 100,000 people across the globe that work on space station. That's almost the size of Vermont. Number of people. We have support from all over the Earth. We have control centers. This is kind of a hard slide to read in here, I'm sorry, but all the different colors, you can see we have different control centers, whether they're managing major systems on the space station, our environment systems, our computer systems, our power systems, or most of these centers are payloads, don't want to use my NASA vernacular, are research facilities where they're managing the different science experiments that are going on the space station. We have 5 different launch vehicles that supply either crew or cargo to the space station. We have 1 Japanese launch vehicle. We have 2 US-based launch vehicles for cargo, and we have 2 Russian vehicles, one for cargo, and one for crew. And here in the next couple years, we will have an additional U.S. vehicle for cargo, and we will also have 2 vehicles for crew to launch from the U.S. So this is kind of the big deal for us at NASA. Even though it's not NASA launching the crew, we don't own the vehicle, we're not building the vehicle, it's still U.S. based. So this was part of our vision to help foster commercial industry in aerospace. So a number of years ago, we actually contracted commercial companies to go build rockets to launch our crew. We would rather do it than have to go pay our international partners to do it. So this is my supply chain. I'm sure it is completely different than all of yours, but it kind of paints a little picture for you for our hardware providers building whatever it is they're building. Let me tell you, we launch a lot of different things to the space station, and Ernest will tell you more about it. But getting that packed, getting it shipped to whatever country it's going to launch from, sending it up to the space station, getting the crew the instructions for everything they're going to do, and then either we have kind of 2 different vehicles that leave station. One, that's kind of our trash can. It comes down and it burns up in the atmosphere and takes stuff away from space station. We don't need it up there anymore. And then we have another one that actually lands in the ocean off the Pacific coast. And then we retrieve that hardware and bring it home. But I'm going to let Ernest go into some more detail about that whole process because he knows it much better than I do.
Can y'all hear me? Hello, testing. Hello, can you hear me? Okay. Good evening, everybody, and I appreciate. I am too impressed, very impressed with the organization. It's fantastic, and it shows just a great respect for the supply chain industry, and the space station is definitely a supply chain type of an industry. My name is Ernest Sanchez. I am the Deputy Program Manager for a NASA program called the Cargo Mission Contract. We are responsible for the transportation, end-to-end transportation and logistics of all the cargo to all the vehicles that Ryan showed you earlier. So we transport cargo to Russia for the Progress of Soyuz and our domestic vehicles. We transport cargo to KSC for the SpaceX vehicle and to Wallops for the orbital vehicle. So as part of that process, we have to do a lot of planning, a lot of analytical and physical preparations prior to shipping the cargo. So you'll see up here on the picture, we showed a couple pictures of some of our packed bags. So when I say end-to-end logistics, what I'm referring to is we have thousands of pieces of hardware arriving from international partners, domestic partners, from local companies that we have to transport to the space station. Each piece of hardware that comes to our facility, we have to know exactly how to handle it. Does it have any unique handling requirements such as shock, temperature, humidity, orientation? We have different hoses and cables that we have to respect bend radiuses on. So all that has to be taken into consideration while we're packing. The other thing is there's not a lot of vehicles that launch to a space station, so we have to be very respectful and try to maximize our density in the bags that we pack. So each vehicle has a certain amount of mass that it can accommodate, a certain amount of volume it can accommodate. There's various different types of bags that we have to pack. And so what we have to do is we have to basically do a analytical planning and assessment of what cargo is going to go onto the vehicle. So some of the challenges we have is with as you all are probably aware, there's always things that come up, and uncertainty of flights is always one of the things that we have to deal with, and it's a reality. Things happen and flights shift. So we have to be ready to react to that. Like Jim was saying, change is there. Change is the space station. It is going to change. It's going to change every day, and so we have to be able to adapt real quickly and accommodate whether there's a failure on the ISS, whether the crew needs something for a science experiment. We have to accommodate at the last minute. So just to kind of give you an idea of what we do on a day-to-day basis is we'll receive the hardware. When we receive the hardware, like I was referring to earlier, we'll do an assessment of what requirements we have to respect when we receive it. We do verifications and inspections to make sure that it's labeled and packaged properly. We then take very detailed imagery, and you may ask, why do we take detailed imagery? And that's because the crew has to know exactly where their stuff is, and they have the ability to go and look at how we pack each and every bag for station. A lot of the hardware has RFID and IMS labels on it so that the crew can readily find hardware on the ISS. And when I say end-to-end logistics, Ryan was referring to, we have two types of vehicles that return. One of them is referred to as a disposal vehicle or a trash can, as you refer to it. The other one is returning actual cargo. The vehicles that return cargo that we work with is the SpaceX vehicle. It splashes down in the Pacific. So whenever the Dragon returns back from the space station, we have to send a team of people up there to go and retrieve cargo. And it's got very critical science and experiments that have to be returned back to Houston within 12 hours. And so we have a team that goes down there and we charter an aircraft. You'll see in the upper left-hand picture there is a snapshot of the inside of an aircraft that we basically, we have people that sit in the aircraft with the cargo as it flies in the air. So we're monitoring the science experiments at very, very cold, -80-degree temperatures to make sure that it's safe and throughout the whole trip. And so that is part of it. The other part of it is we have to transport all the other cargo that returns back, and we get probably around about 1,000 pounds, maybe a little bit more than that, of cargo that we return back from a SpaceX mission. So we sent a team up to California to basically assist in the unloading of the Dragon and the loading and safe transport from California back to here to Houston. So some of the other things that a lot of people take for granted, you'll see some of the specs here. Over 16,000 pounds of cargo that we ship to the space station every year. That is a lot, and that goes up typically with around 10 to 12 vehicles per year. And within those vehicles, like I was telling you earlier, there's different types of bags. So that we put that 16,000 pounds in approximately 500 different sized bags. The vehicles are all designed very similar and from a volumetric and loading perspective, in that we have the same bags that fit all the vehicles. It's just some vehicles accommodate different size bags and can accommodate different masses. So one of the other things that we have to respect, obviously, is the launch vehicle is very sensitive to CG. And so one of the things that our team has to do is each and every bag that we pack and process has to be within a certain mass. So the bags are certified to a certain weight. So not only do we have to meet weight constraints, but we also have to meet CG constraints. And then we pass that on to the vehicles so that they can properly account for that when they're doing a launch and reentry. Some other things you'll see here is that we process over 6,000 items. So every single item that we process is assessed for its requirements. So when we say end-to-end logistics, that means having to meet all the domestic DOT, Department of Transportation requirements from our facility to the launch sites, whether they're domestic or whether they're international. So we have to respect any types of hazards, any types of DOT special permits that we have to meet. So as you can imagine, we have pressure vessels that we have to ship to the station. We have hazardous chemicals, batteries, all kinds of hazardous materials that we have to properly label all of our shipping containers to get to the next level integrated. And here we have about 650 shipments, so that's a lot of shipments that we do annually. So 650 shipments that we transfer out of our facility. And some of these shipments are small, and some of them are very large. And when I say some of our larger shipments are orbital flights can accommodate. Am I static? Our orbital flights can accommodate around 3,500 kilograms of cargo. So that's about 7,000 pounds of cargo that goes onto the vehicle. So that's a lot of mass there. And our shipments, as you can imagine, when we ship internationally, sometimes we have to ship items that are not easily exported or imported. So we do diplomatic transports as well, hand carries, where we go to Washington, D.C. and use the State Department to accommodate that kind of a transport. We do a lot of hand carries of common goods into Russia. Most of those goods are associated, and the reason they're hand carried is because of either shelf life limitations or temperature limitations that we have to respect throughout the way. And some of our, within those shipments, if you can imagine, we're packing thousands of items for each shipment. We have to basically envelope the requirements and understand what our minimum maximum temperatures are, what our minimum max shocks are. Does hardware have humidity requirements that we have to respect? So during these transports, we put in monitoring devices to monitor all these environmental conditions from point A to point B, so that we can assess it if it gets to the final destination and something, something didn't turn out the way we expected to. The other piece of our contract, we do end-to-end logistics, but as part of that logistics, one of the things that makes it very efficient for our contract is we also manage over 1,000, I will call them line items or different types of products. Those products range from laptops, cameras, cables, iPads, anything you can imagine you would use in your everyday house, power supplies, power adapters, those common articles, crew clothing, shoes, a lot of personal hygiene products. So all those products are also processed by our contract and have to be processed. So when I say that we have maintained over 3 million items in inventory, as you can imagine, this is a government contract, so we got to make sure and account for every single item that comes in and out of our facility. So we track the items from when we get it in our back door to when it gets to station and to when it returns. So some of the items get disposed of, and we'll properly account for that in our property management system. But each and every item that comes into our facility, it is tagged and monitored throughout its entire life cycle. One of the other things that our contract does is, you can imagine, from an inventory perspective, trying to manage all that on the ISS, International Space Station, could be quite cumbersome. So one of the things that our contract does is it develops a product that we give to another organization within NASA to help maintain and build their inventory system to make sure that we know exactly what hardware and the amount of hardware we have on the ISS. And that's very important. So we have to track usage rates of different types of products so that we're able to resupply the crew the hardware that they need to sustain their activities and their science projects. Let's see here. So our contract, the very last bullet there says that a cargo packing for delivery to and from space station, consisting of pressurized and unpressurized cargo. So our contract deals with the pressurized cargo, which is basically the module that gets berthed and mated to the space station, where the crew goes and extracts the cargo. The unpressurized cargo is done either robotically or through EVA or other means of activities. So that's what that means. And you can see on the bottom right-hand picture how tightly packed one of those is. That's the kind of an example of one of our bags. And then on the top right-hand side, you'll see how that's packaged. And one of the other things that's very critical for our contract is from an environment perspective on the ISS. Like I heard someone talking about, we have to respect things like alcohol content on different types of wipes and products that we use, so it doesn't affect the integrity of their water system and oxygen system. Let's see here. One of the things I wanted to show y'all is kind of a picture. So this is a snapshot of a transportation route that we do for our shipment to Japan. So you can see that we have different trucks, planes, and boats to get us to the final destination launch site in Tanegashima. And we launch the HTV vehicles about once a year. So you can see there's a lot of logistics and coordination that has to occur as part of this contract. And so it definitely keeps us busy. So that was I'm going to hand it back over to Ryan. And I look forward to answering questions that y'all might have. Hopefully you do.
Good? Can you hear me now? Okay, good. I just have a couple more charts. I talked about Reagan's view for space station and how we still have that today. The primary purpose of space station right now is to do that fundamental research. And we have a lot of different types of science we do on the space station, from physical, biological, chemical, combustibles. We do plant growth. We have experiments outside the space station that are investigating different materials and how atomic oxygen affects those materials that can be applied back down to actually some of your industries down here on the Earth. A lot of our research in the biological area is focused on I'll say two main areas. One are major problems that we're trying to solve for the human race down here. New drugs for cancer treatments for osteoporosis, which not only affects a lot of people down on the Earth, But that is one of our major concerns for exploration beyond low Earth orbit. And how are we going to maintain the health of our crew when they are out of gravity for an extended period of time? Everything we're learning with our human research on the space station can be applicable back down here on Earth. And so it's kind of this dual purpose. And I can talk more about that. I will, one stat, we've done over 3,000 different experiments on the space station already. In any single increment, which is like a 6-month chunk of time when you have one crew set up there, 200 to 300 experiments every increment. Not all of them crew tended. The crew doesn't have to do everything for every experiment, but 200 to 300 total every 6 months. Our next step is commercial space. I talked about this as it was part of Reagan's vision. It's still part of our vision today. Part of how we're doing it is we now have commercial vehicles that's launching our cargo to the space station. But we also reach out to the commercial industry in other areas. CMC is a commercial contract. Leidos is a different company from the government. We have different facilities on the space station that were built by commercial companies that different experimenters from government, from academia, from other commercial entities use their facilities to run their experiments. And so it's becoming this partnership different than how we thought of it at the beginning. It was just government, right? I was the customer, I was the government, and I had my international partners. Now my partnership is expanding. It's a whole different ecosystem surrounding how we manage and operate the space station. The idea in trying to foster a commercial industry in low Earth orbit is so I can have a commercial company do it, and I can use my government funds to go beyond low Earth orbit. That's our big goal, is what do we need to do to continue human exploration beyond our planet? This is a picture of, kind of some of our vision for how we're getting there and a timeline. You can see space station on the left, conducting missions around the lunar surface to figure out more of what we need to know to go beyond low Earth orbit and eventually onto Mars. This, I think, is my last slide. So if you didn't know, you can Google Spot the Space Station. You can put the app on your phone and you will get text, and you got it? Nice. Text and emails about when the space station's flying over. And I actually put up here July 1st and 2nd, it's flying over. There's some pretty good views, and so you can see it. It's really, I find it really neat to see. My kids don't care anymore. I get all excited. I'm like, space station's flying over, let's go outside. Like, oh, Mom, we've seen it a million times. It's just so cool. You can see it, right? You helped build it. Anyway, I'm sorry, I should be done, but I realized I didn't even tell you what I do. I didn't even tell you my job. So I know Judy mentioned mission integration and operations. My job, end to end, this is how I explain it to my parents because they're not in aerospace, is I manage kind of the end-to-end process of the entire integration for what we do on a space station. So all the way from when we're going to launch those 5 vehicles I told you about, I plan the schedule for when they're going to go to the space station. I am the primary customer for Ernest contract, so not only what we're going to pack in those vehicles, but then how we're going to do it and what vehicle we're going to put everything on. And also part of that is I manage all the food and clothes, and we send ice cream to the crew. That's a big deal right now. And then what the crew is actually going to do with everything we launched. What science experiments, what maintenance, what systems activities is the crew going to accomplish? And then once everything comes home, what did we learn? And, you guys talked about lessons learned in your whole process. We do that too. We have a lessons learned discussion after every single mission. And so I get to do the entire integration. We're kind of like the hub of the wheel for space station. So it's pretty neat. I get to see kind of a broad brush of everything that goes on. So that's all I have.
So I'd like to invite our panelists up. Jim, if you'll join us up here, please. So we're going to ask a few questions of our aerospace experts here, as well as Jim, our APICS expert, to kind of give us a little bit more overview and understanding of what's going on. So we wanted to start with the IAS technology that's come such a long way. And it's now a package delivery system. And so, I'm sorry, no glasses. Consumers can purchase these the drones today without any kind of special approval or anything. So with what is NASA currently doing in the field of this unmanned aerospace systems?
Are you asking me? I have
Yes.
no idea. I'm sorry. I don't do drones at all. I only do human spaceflight. I don't know if you know.
Ernest, okay, so I apologize to all of you. That's
okay.
I was supposed to pass on that one. But I was really surprised to find out that the drones is something we consider to be part of the aerospace industry. And recently my daughter and her friends were in a film, and they actually used the drones to film that, so it was pretty interesting to me. So we talked about the additive of the manufacturing. It's been around since Reagan. However, the technology didn't gain the opportunity until this decade for the aerospace industry and most of the government. So what impact has the additive manufacturing made in the aerospace supply chains?
Yeah.
That would be one of Ernest's questions, I believe.
Which question?
Your additive manufacturing process.
You talking about the 3D printer?
3D print.
Yes, the 3D printers, yes.
So I don't have a lot of familiarity with the 3D printing process. There is a couple active operational 3D printers on the ISS program, and one of the things, sorry, is that me? So one of the things that we supported a couple years ago is we were able to actually generate a CAD model and send it to the station so they could produce a 3D nozzle that was needed for a vacuum cleaner. So that was a good example of the use of a 3D printer. We do have a 3D printer at our facility today that we use for mock-ups and so forth, but it's the materials that are used within it are not acceptable for the flight environment. So we have to respect the flammability and off gas to ensure the safety of the crew. But we are investigating another 3D printer that does have materials that we feel is acceptable and can be flight certified to be used. With that, I think it comes great opportunities to be able to quickly manufacture and produce products really quickly and reduce that cycle time significantly. So I see great advantages to a 3D printer in the future if we can find materials that can be used on the ISS.
That's amazing. Thank you. With all of the forces that are surrounding us right now, what do you see the drive in the supply chain that would be impacting the aerospace industry? What forces drive your industry?
Oh, so from a space station in general, so I don't know if it's completely applicable to supply chain, but I'm a government employee. Congress drives a lot of what I do, right? Every year, we have to make sure that we get our funding. Our international relations and making sure that we're building those partnerships and utilizing the best of what each partner has to bring to the table drives our industry. How we can go best partner with the commercial sector and build that economy. Part of what we've been focusing on as a government entity, sometimes you don't mesh very well with commercial industry, right? We have a lot of process, we have a lot of bureaucracy, and we have been focusing very diligently in the last couple of years about how we need to change. I love what Jim was talking about earlier, and change is kind of a constant, and we've been going through some massive changes in our culture to better align ourselves, better align our vision, to empathize really with the commercial sector so we can be more agile, so we can attract commercial industry to work with us as a government agency. It's a big mindset shift for us.
Thank you, Ryan. What impact has the Internet of Things had on the aerospace industry?
I don't know what that means.
Yeah, that's a good question that I got fed here, so that's not fair. No.
I can try and answer if you can explain to me what the Internet of Things is.
We talk about just the use of IT tools in the environment and security and that kind of stuff. Or, you know, I think, you know, from an automation perspective, we have gotten a lot more efficient with our tools. You know, we've evolved our processes to become more efficient. If you don't change and find ways to be more flexible and more efficient with our processes and our tools, then you're missing out on a lot of opportunity there. And so we have definitely evolved our IT infrastructure and use of the internet and accessibility of our IPs to allow them to access some of the sites that they can that we need them to in order to make it easier for the end-to-end cycle time for all the data products that we need from our customers.
Okay, thank you very much, Ernest. Appreciate it. Okay, in January of 2006, NASA's Commercial Crew and Cargo Program Office, which this has to just be, I'm not a Star Wars person, so you have to tell me, was C-3PO before or after y'all came up with this acronym?
I don't know.
So the team created the Commercial Orbital Transportation Services Program. The focus was to provide capabilities to commercial companies to deliver cargo to and from the International Space Station. A decade later, the commercial space industry is thriving with many participants. What is the ISS, NASA at least, doing to boost that commercial activity?
That I should have held my answer because the last thing I just said is perfect for the answer to that question. We put that contract in space, and that's what Orbital ATK and SpaceX do now to ferry our cargo up and either home or dispose from the space station. But really what we're doing wholeheartedly is trying to change our mindset, to change our culture to be able to interface with the commercial sector.
Absolutely. Thank you, Ryan. Ernest, what are some of the challenges that you have to overcome with the processing and the packaging of ISS cargo? I think you talked a little bit about that in the presentation. Can you expand on that?
Sure, absolutely. So I think the biggest challenge, I think, is the launch date uncertainties. I think is probably going to be our largest challenge because if you can imagine, you know, you pack all these bags and you're trying to get it to the crew, and then all of a sudden there's a problem with the vehicle. So now you have to adapt and almost repack a whole other vehicle for a whole other vehicle. So that does probably cause the biggest challenge for us. The other challenge at times is a lot of times we're reacting with a very short fuse. So I think hardware availability at times can drive some challenges for us, and having to pack at the last minute is sometimes hand carry or diplomatic carrying to Russia, those kind of things. So I think the challenge is really availability of hardware, flight uncertainty, and at times we have logistics challenges with regards to transporting of some of the more hazardous products that we have, like pressurized vessels, to ensure that they're safe from point A to point B. So I think logistics and the launch uncertainty and just the I guess that's probably it. So.
And then the next question is very much related, and it's talking about the different launch sites. And just last night I was watching the news, and they were talking about the Red Cross getting ready to try to figure out where the tropical storm was going to land, and having to have all the emergency centers in place in case it was the other launch center. Do you have a similar situation that you have with all the different launch sites?
Yeah. No, because we can't launch that quickly, right? So we don't have that quick turnaround. Although I will say, when we get to commercial crew, as we call it, we will have options of different landing sites, right? So for cargo vehicles around the space station, you can just wait a few days if there's a storm out in the Pacific. No big deal. We'll just hang out on the space station for a while and eventually bring them home. When you put humans in the mix, it becomes much more critical for your timing for when you can bring them home. So we will have options in the future of, say, landing on the East Coast versus landing on the West Coast, and we'll have to respond from a logistics perspective where we go pick up our crew and cargo. We just don't have to deal with that right now.
Okay, thank you.
You know, some of the things that the community may not realize is it is a 24/7 job as far as monitoring the space station and the safety of the crew. so that at every minute of the day, there is somebody at Mission Control monitoring the health of the space station and the needs of the crew to be able to react to failures that occur. So, I know that our contract has to react. Has to react to some of those off-nominal failures that occur. So one of the things that when you talk about contingencies, obviously all your data system and communications have to continue to operate between Houston and the space station. So if something happens here in Houston, we have alternate sites to transfer that mission control to a different facility to continue the monitoring of the station and maintaining the health of the crew.
Thank you. For Jim, I was wondering, where do you see the diversity that you were talking about earlier to be in, that is in the workforce? Where would you see that applying in the supply chain? And
Sure. Turn the mic off. I'll turn it on. Let's see if it works this time. It does. The association is very focused on what we call. Can you all hear me? Nope. I am jinxed. The association is very focused on what we call aggressive inclusion. So if you look at our group tonight, our group nationally, we want to have deeper participation from our constituencies that have always been involved, but we look beyond our traditional groups of participants to see how we can extend. McKinsey did a study that companies that are gender diverse are 15% more likely to outperform their competitors. In that same study, companies that are ethnically diverse, 35% outperform their nearest competitors. And I don't know if you've seen at the back of the room, there's this study done in conjunction with Manufacturing Institute, Deloitte, and APICS. Women in supply chain. And hopefully you'll be attending conference this year. It's in San Antonio, Texas. You have absolutely no excuses. It's a lovely city. And we're going to have a sub-conference within our conference about women in supply chain. And this particular study surveyed 600 leading women in supply chain, did over 20 interviews. It is predicted in the next decade, U.S. manufacturing will have 2 million unfilled positions of key workers. Today, manufacturing executives say they have 6 out of 10 key positions are unfilled. So for us, we believe that by focusing the might of this great organization on how we can become more gender and more ethnically diverse is going to be a benefit not only for the association, but for the economy, because again, people build supply chains build companies, and companies build their economies and help people. So yeah, it's pretty exciting stuff.
thank you. And also in that, I'm not sure if it's the same study or another one, but you were looking at women in the C-suite and what impact that has on organization. Can you explain a little of that, what you've seen?
Yeah, I think it's just along the lines that organizations that benefit from diversity, whether it's gender or ethnic diversity, are more likely to be successful. So including women in the senior ranks. And it's an important thing for us as an association to focus on. So I think it's just more of the same, but important stuff.
I'm going to take a little liberty here, and since we're all here to learn, and we found that there's so much we can learn from each other, Ryan, I think one of the first things we were talking about was, well, actually it's going to be a question for Jim, but when we were first talking, this question is going to be for Jim. Ryan, as we were first talking, one of the first things you mentioned,
I'm happy to donate it to Ryan,
was that you weren't sure that you were actually in supply chain. And so I was wondering if Jim could kind of explain, after she's explained her role, where in supply chain she might fit.
What an incredible question. And I almost would like to leverage the capabilities of the audience to help explain that.
So you have the handout up there. Go to the supply chain rules.
Okay.
No, next week.
Okay. Well, maybe we can get to that question. What a wonderful question. I feel
Okay,
fully
while
stumped.
you're reading that page, if you'll hand the mic back to Ryan, I'll toss one to Ryan and
Okay.
Ernest. So while he's helping us to educate the aerospace industry for the other side, a lot of us in this Houston area, as you heard earlier, are exposed to oil and gas, and so with the dip in the economy, there's a lot of us who are displaced workers. So could you share with what you've learned about supply chain so far, where you might see some transferable skills that someone might be able to, I was going to let Ryan and Ernest explain where they might see that our oil and gas skills. We'll get to you.
I'll let Jim answer. But how about, I don't want to pretend to talk to skills in supply chain, but I will talk to skills that I value in my work, if that will be of use. And you touched on it on your charts, right? It's both the hard skills and the soft skills. And even in an aerospace industry, even as technically astute and competent as we need our engineers to be, who are building, designing, testing, and flying this hardware, it's hardcore engineering. It's electrical, it's aerospace, it's chemical. But they have to be able to talk about it. They have to be able to present and be able to think through a thought process about how to solve a problem and how to scope that problem and how to write it down for management to understand it, to then be able to do that higher level risk trade to make decisions. It's all about communication, decision making, and you can't do that well if you can't talk about the technical problem you already know how to solve.
Thank you.
My opinion.
Ernest, do you have anything to add to that?
No, I agree with Ryan, but what comes with the soft and hard skills, we have a broad spectrum of different types of skills that we need for the ISS program. And in our contract, we need just about every engineering skill out there, technical, non-technical skill. So it is, it's definitely not any kind of specific skill that's needed for the aerospace industry. We basically, it could be medical skills, it could be transportation skills, I mean, just anything, you name it, the ISS needs it.
Thank you. Jim, back to you.
Yeah, I mean, is it, can you hear me?
Yes.
Okay. I think that it's never easy to make transitions, particularly to a new area, because, people are funny. They like to put people in boxes. So you've spent your career in the oil and gas field. So automatically you get put in a slot. But here's the beauty of the APICS body of knowledge, the training you have, but beyond APICS. What you have learned in your roles are absolutely transferable to other areas. I can tell you this. I made a transition in my career within the last 24 months. I spent my entire career in the Internet of Things, even though I didn't answer the question. Just so you know. I spent my entire career in the Internet of Things in the for-profit world, involved in running and developing global channels. And I wanted to make a change. And I had the realization early last year that I wanted to make that change. So what I did is I began to really look at my skills a bit abstractly. Not in the acronyms of the world I came from, but abstracting those skills and how they could apply to other areas. And certainly, the opportunity for APICS was presented to me. And so what I would suggest is this, is that don't cut yourself short. Don't allow people to put you in a box, paint you in a corner. Give yourself credit for the universal capabilities you have developed in your careers. And know that the APICS body of knowledge, the language that we give people to help do their jobs and to interface around the globe is transferable to many different industries. So I think a lot of it is, there's a little bit of all the preparation, giving yourself credit for what you've done, and then just the belief that you can make that change. There's that little magic you have to have as well, but I think it can happen. I don't know if that helps at all.
Yes.
But I think it definitely can happen, and I witnessed it in my own career.
Thank you to each one of you. We have time to open up the questions to our audience. Oh.
There you go. You're welcome.
Hi, can you hear me? I have a question for Ryan. So you mentioned you spent about 20 years in NASA already. So what was your first job and what do you think made you successful in that industry?
So my first job, I was actually in the operations division. I was a certified flight controller. I was what you call a communications and tracking officer. I was actually, you'll appreciate this, I was the first female certified communications officer for Space Station. And I spent, when we first launched the space station, we didn't have a US communication system. I had to learn Cyrillic so I could tell the flight director what the Russians were communicating. Yeah, no, not so much. Yes. I know I can get around the metro and I can order on a menu, but I can't speak it. But I did. I lived in Moscow for 3 months, and I traveled there a number of times because I got to help build up. We have a liaison office in Korolev, in the soup, and so I got to kind of define how we would interface as operators between the Russian flight controllers and the U.S. flight controllers. So that was my first job. I was a console jockey, and I would sit on console for sometimes 13 hours at a time, and I would be like one of 2 people in the entire world watching the space station go around in circles before we had a crew up there. What made me successful? So I don't know that there was anything specific I did in my job, but I'm a very determined and driven person. So I have a kind of a life philosophy that every morning when I wake up, I'm going to be better than I was the day before. And so if I'm a lifelong learner, I tend to try and learn something new every day, and then sometimes my lessons are a little hard if you mess something up, right? But you learn from it, and so the next day you come back and you try and do it a little bit better.
Here's an open question. I was wondering if any of the research done on the space station has improved solar technology, and if any of those improvements in turn have been or will be incorporated into those impressive solar panels.
Pretty cool, aren't they? Actually, so I wish I could talk more about what we learned from our huge solar panels. It's on space station and how they're being applied on the Earth. I can probably find out for you, so come find me after and we'll connect. I will say that while the space station today is generating enough power for absolutely everything we need, we have a surplus of power. So in addition to those solar arrays, we have batteries. So when we're in we call it insolation, but when we can't see the sun, we run off battery power, and it's just a continuous charge-discharge cycle on the batteries. We are actually still investigating different types of solar panel technology. If you go to YouTube just from last weekend, we have what we call a rollout solar array, and there's some great video out there about a new space station or new solar array technology that we just put out last Saturday, and we're going to take it back inside this weekend to see what we can learn, to see 2 things. Is there something we can do to add to our capability for our systems today? And what do we need for our future vehicles for Mars?
I have another question here in the back. Can you hear me?
Yep.
Hey, I just want to have your opinion about now with the creation of the SpaceX, the company from Elon Musk. How do you see that? Do you see that as a partnership? Do you see that as a competition? How do you see that in the future of NASA?
That's a great question. My perception is, outside of aerospace, people just like to watch conflict on TV, right? And so I think people like to look at it as NASA being in competition with SpaceX. I will tell you, inside in the space station, we very much see them as a partner. They are our partner in launching our cargo to the space station. If they don't succeed, we don't succeed. So they have to be successful. We've had a couple SpaceX failures in the last few years, which is completely expected. It was in this is going to sound horrible when I say in our plan, we have to be prepared to lose brand new vehicles. This is hard. Rocket science is hard, and so we have to be prepared to lose these new vehicles as they're still in really their design and learning phase. But it's difficult when we lose them. When they're on the ground, I'm not launching my life science, and my life science is my lifeblood right now.
I have a question for Ernest. I know that technically the space station and everything else, and you just touched on that it requires redundancy. You have to have backup. In your supply chain, how much of that redundancy do you have as far as material, transportation, all of that? Do you have that same level of redundancy?
Well, once we, can you hear me? Can y'all hear me back there? So from a transportation perspective, I would say that we do at times try to have alternate plans in the event that one of our trucks is unable to make it. So we do try to double book when we're at a critical state. Sometimes we'll have backup plans with hand carriers, if those kind of things. So I think it really depended upon the situation, the urgency of our shipments. So a lot of times we have a certain window of on-dock date to our visiting vehicles, which is the launch sites, and so it allows us a little bit of a play in our schedule. Maybe we get a day or two that we can ship early in case something happens. You definitely got to be able to react. We've had situations where we've had normally when you contract with a freight forwarder, a lot of times when it's a straight point A to point B to the end destination, there'll be two people on the truck. So we've had situations where people have gotten sick and had to stop over at a hospital, and where we've had to take the cargo from one truck to another truck. We've had situations where trucks have just broke down, where we have to coordinate another truck to pick it up. We've had situations where hardware's been accidentally left on the tarmac and froze. So we have to be able to react to those type of things. But once you put the cargo on a truck, it's hard to have a contingency, so all you got to do is be able to react to those things that are unexpected. But absolutely, we try to have contingency plans for as much as we can, but when it comes to our shipments, sometimes we're somewhat limited. As far as the cargo, like Ryan was saying, sometimes you have to expect that you're going to lose cargo, or cargo's not going to work, and so you have to have backup. So on the space station today, they have what's called what's it called? On-orbit spare process, where basically we have a lot of critical ORUs, and so there's a lot of redundancy on ISS in case something does happen, that they're able to react and use the spare. So how that impacts our contract is we have to start thinking about how we can get that next spare up to ISS. And so a lot of times when they're reacting to failures, we know that our contract's going to be impacted, and we're going to have to go off and try to find room for that one last item to stick on it before they launch.
It's been mentioned several times tonight that the International Space Station is the result of the collaboration, the deliberate collaboration of 4 countries plus one conglomerate, the European Union. With all the tensions going on in the world right now between the U.S. and Russia, have you seen any deterioration in that? And it may be a question you can't answer.
I can actually. It's a really good question, and I actually get asked this question quite a bit. Believe it or not, no. It's being in this industry and working on this enterprise that is space station is almost like being in our own little bubble. Everybody who is a part of it is so completely passionate about the mission, and we have human lives at stake. When it comes down to it, we are working to get it. We're a International Space Station community. We are not the United States. We are not Russia. We're not France, or whatever countries you want to look at. It does get difficult. We do have intergovernmental agreements with different countries that allow us to have that kind of partnership. Where the difficulty comes in for us is when those are expiring, or we need literally an act of Congress to go extend some of our agreements. That's really where we run into trouble. The day-to-day working, and when we're working anomalies, or we're just trying to ship cargo back and forth and do whatever we need to do, there's no issue.
You had mentioned something on the research that could be applicable to consumer products, or at least commercialized to some degree. And we keep reading about how the inhabitants of the space station undergo some loss of bone density, muscle mass, relatively pronounced. You mentioned that as an area of possible research. So question one, have they found any of the factors? What causes that loss? Two, any way to ameliorate that? Has it been reduced? And then three, if they have found something like that, how does it get handed off to private enterprise? I mean, it's been a few decades since we've had Tang or space food sticks, the latest development. But if they found something that actually reduced osteoporosis or built muscle mass, whether it's a pill or an exercise program, somebody could make some money off of it.
Yeah, actually, and I wish I had it off the top of my head, but there was a publication in the Journal of Medicine, it's been a number of years ago, where we made great strides in understanding why the astronauts experience bone loss. And it was a different combination of exercise protocols as well as nutrition, reducing sodium, increasing certain vitamins and minerals in their diet. And the study was phenomenal, and the results that we saw in the astronauts and making those changes made quite a difference. I'll see if you want to connect after, you can send me an email and I can get you to that article.
Hi, yes. I've noticed that many times you said space station instead of the ISS. Is there a reason for that?
No, it's faster. It's the only one up there, so I just cut it short.
One of the things we learn in APICS is about scheduling factories. And there's always a reason to have to expedite this, that, or the other, all kinds of pressures. You're scheduling 5 vehicles to go up there with who knows what. I would be fascinated to know what kind of pressures you have to deal with about expedite this. No, I have to go first. It'd be fascinating.
Yeah, I wish I would have thought of bringing that we have this most amazing picture of how we track up and down of these vehicles. And I could sit here and tell you we get to schedule when we launch these vehicles. That's honestly the easy part, because they can only go when they're ready, and they have their own timeline for their vehicle readiness. And they have, for SpaceX, they're launching every 2 weeks. Okay? So they have a window for us to go, and they need to be ready to go, and our hardware needs to be there to fly. But there are other factors when they're trying to go to the space station, what comes into account. When is the crew coming and going? They take priority. So we have to schedule around those Russian vehicles. The Russian cargo vehicles are on target. They have been flying for decades. They don't slip. They rarely have issues. So we tend to schedule around them because we know they're going to go. And so it's this very fluidic, well, we also have to take into account what's the crew doing. They might be in the middle of some critical science activity that we don't want to interrupt. It's like your in-laws coming for summer vacation. I don't need the interruption when my crew's working on whatever they're working on, right? And so that, where the sun is in the sky in relation to the space station, makes a difference. There are certain times of the year where it's too hot for vehicles to come to the space station. There's too much sun on the vehicle, and they can't handle it thermally. So there's all of these factors that come into picking those dates. It's actually fascinating. I'm really glad I have very smart people who work for me.
So when Judy asked the question earlier about the Internet of Things, my brain started spinning. Oh my gosh, what about all of this? So even though you weren't able to answer the other question, Ernest, when you started talking about RFID chips, I started thinking, well, I wonder, does the International Space Station utilize any type of Siri or Alexa type communications that the station can communicate with the astronauts? And if an astronaut forgets where they left something that has an RFID chip, can they say, where did I leave my such and such? Because I wish I could do that at my house.
Yeah, so that would be awesome. I would really like to have Alexa on the space station, for real. Ernest mentioned the IMS, inventory management system. We're trying to launch everything with RFIDs, and so the crew can actually go look on Yeah, and they scan it. The crew can go look on their laptops or their iPads into the system to find out where something is, or they can just call the ground, because we share the system between the ground and the crew. Usually it's easier for the crew to just grab a mic and say, hey, where is this? And that's what they do right now, but Alexa would be nice.
They do have there is a science, I think it's called Realm, is that correct?
Yeah.
So it's an RFID type of experiment where it's a robotically operated device that basically goes around and scans areas to identify cargo based on RFID. So they are moving toward that.
It seems like if you were going to come up with that, HAL would be a good name.
I like it. Might freak some people out.
For time's sake, we're going to ask just 2 more questions, one here, and if I have one more burning question, and then we're going to wrap it up for the evening.
Well, I'm going to bounce this off Hal right now. Fascinating stuff. I'm glad you guys are here. It makes APICS fun, right? Okay, the movie industry. I think it's been kind to the industry, space right now. The Martian, I loved it. Hidden Figures is a fantastic movie about your history. You mentioned Mars before. You've been on the space station, or the space station's been in existence since 1998. Okay. When is Mars? And is that a possibility in our lifetimes?
I wish I could tell you when it is. I don't know. A lot of that answer revolves around when we can have funding to go do it. There are some technologies that we still need to go develop, which teams are thinking about and people are working on. It's a matter of, I work for the government, I work for the agency, and so I have to do what the administration and what the agency puts forward for me as far as priorities. So I'm only appropriated to work on certain things in a certain time frame with a certain amount of money. And so I can't answer all your questions because I don't know yet what this administration is going to do. But I can tell you we are working in technology, and as you saw from my slides, it is a part of our conversation within the agency, not as much in the space station, but definitely within the agency. How are we going to get there?
Hi. An article came out recently about some technology called an M drive that uses microwave radiation for propulsion instead of, the current, solid rocket type stuff. Is that, supposedly it's peer reviewed and all that, is it real or is that hokey? And
I'm sorry, I don't know.
It looks like a copper kettle. It's got microwaves in it, allegedly.
I don't know, but now I'm going to go look it up because I haven't read that yet. I'm fascinated.
All right, so I know that many of you have questions, so sorry that we have to stop it here. Thanks everyone for your interest. Thank you to the 3 of you for participating tonight. Really appreciate you sharing the knowledge. So can we give them a round of applause?